Teaching AI to students is a real challenge. It's an incredibly fast-paced and complex field, so there's a lot of hype out there and a lot of information to sift through, and you need to be able to filter that in order to effectively teach the topic. In my experience of both learning and teaching, learning AI needs a mix of theory and practice. On the theoretical side, there's all the techniques underlying AI, usually drawn from maths, computing, and engineering. In particular, I think AI on the edge brings all these subjects close together, because in order to build models that work on the edge, you really need students to understand the theory of what they're doing, but also how that interacts with the specific hardware that they're using. The practical elements for learning AI come in various forms. Sometimes those practicals can run alongside theoretical elements to reinforce the learning. Other times, I think a really effective way to learn AI is project-based, where you really aim to push the boundaries of what students know and understand, and get them thinking beyond just the theory they've learned. Practical AI work needs computer programming. A lot of AI programming today is done in Python, but sometimes can be in R or other languages. There's an awful lot of open source material out there, code and models, to learn from, and tools like notebooks and online coding environments that let you experiment without having to set up your own local environment. Students can get really far today if they're able to make use of what's already out there. I think that project work is particularly useful because getting AI working is a practical skill. Sometimes it feels like there's a lot of intuition involved. One of the lessons that I've learned from building models in industry is that working with AI is a very iterative process. You need to start by thinking very carefully about the task that you're trying to solve and what you're trying to achieve. Then look at the data you have, build a model, investigate how well it's working or not working, and continue to iterate around this loop. There's a real need to spend time with the data, understanding what it is and how it impacts the model that you're building. Evaluating the model properly is also important, to know that you're building what you think you're building. Other practices, like starting small with a small data set and getting the code working before moving on to work on a larger set, can accelerate your work. Bringing some of this real-world AI experience into the classroom in the form of an open-ended project can help students be more successful. Project-based work can also encourage teamwork and collaboration and bring a range of perspectives to the table. It's really important too to widen the appeal of AI education, to appeal to our diverse audience and make the topic accessible to students across a range of backgrounds. AI, as we know, isn't a diverse field, so how we teach it can really help to broaden the appeal, broaden the perspectives that we hear, and diversify the field. Another challenge is managing the fast pace of change in the field, being able to stay relevant and up to date while keeping a high quality of teaching. The challenge then is teaching AI in a way that cuts through the noise, combines practical and theoretical knowledge in a way that appeals to a broad range of students, and inspires them to build practical and realistic solutions to the societal problems we face.